Hi, algebranarians. This is Mr. Kong. I'm talking about section 2.1 today, relations and functions. All right, the first thing we're going to take a look at is the definition of what a relation is. A relation is just a set of a pair of numbers called an ordered pair, x comma y. That's usually how we write it. X is known as the input value and y is typically known as the output value. You'll also hear these x or input values known as your domain, and the range is your y's or your output. We have special relations in this world. A function is a relation where the x doesn't repeat. Okay? All right, so taking a look at these ideas, let's see if we can do some simple examples. And again, I think this is probably covered in Algebra 1. That's why I'm kind of going quickly through this. In these examples, I'm given a list of ordered pairs. All right? I want to state the domain, so state the range of each. In A, the domain would be, and we use a little bracket or brace here to represent this set. The domain are on my x's. So in order from smallest to largest, be 4, 5, and 7. In my range would be all the y values. So the smallest is -2, followed by 1, followed by 4. So that's your domain and range for that problem. Now, since 4, 5, and 7, none of those repeat, this is a function. In the next example, in example C, my domain is -1, 4, and then 9. My range would be C here. The smallest y value is 3, and then I got a 6. Oh, and I got another 6, but since that 6 is already listed out, I don't list it out twice. You don't need to repeat numbers. Okay, now, if I looked at did any of the x values repeat? 1, -1, 4, or 9? Yeah, so because of that, that's a function. Notice I care not one bit if the y values repeat. It's only if the x values repeat. Okay. You guys try and do B and D on your own. All right, now let's take a look at the next idea. The next idea is if I actually graphed out those points on a graph. Suppose I was given these 5 points on a graph, and I wanted to state the domain and range of this. Well, there's a couple of ways of doing this. The way I'm going to do this is I'm going to list these out in an XY table. The first point on the left, and I typically go from left to right. The first point would be -3 for the x and 1 for the y. And I've got -1, -1. And then I've got 1, 1. And then I've got 3, 2. And then I've got 3, -4. By listing these out in an XY table, I can see that these x values right here repeat. So this is not a function. Again, it only takes one pair of x's to repeat for it not to be a function. Now, that's by taking these points and actually putting them in an XY column. Right? Now, if you physically notice, the 2 points that caused this not to be a function were this point here and this point here. Now, what is the relationship you notice about these 2 points? Well, as you can see, they're vertically right above each other, right? Well, there's something called the vertical line test. And the vertical line test basically says that if at any point, if you imagine a vertical line going across your graph, if at any point in the graph 2 points touch that vertical line at the same time, then the relation is not a function. So in this case, this is not a function. Now, let's take a look at the next problem I have here. If I take that vertical line that I'm imagining so that I don't have to write out ordered pairs, if I were to drag this vertical line across my graph, let's see here, it goes across 0 points, no points, no points, no points, no points, no points, 1 point. 1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1.1. no point. Notice that it never touches this graph at more than one point at a time. So is this a function? It is a function. Now, what about the domain and the range? Well, take a look at the difference between this graph and the graph I gave you in the problem up above. In this graph, where I have singular points, my domain and range is not continuous. Whereas in this graph, the graph actually is a continuous graph from -3 on the left to +3 on the right. Notice that in here, this curve actually has decimal values for x. Like, for example, I could say that at -2.5 on the graph, there's actually a point there. So from here, it is impossible for me to list out the domain as individual values. So what do? I use our old friend interval notation. Interval notation says, where does this graph start and where does it end? Well, it depends on how you want to look at it. We can say that this graph, for domain, my interest is the x values. Well, that's the left side of the graph to the right side of the graph. Where does this graph start on the left? It starts at -3. Where does it end on the right? It ends at +3. Now, again, with closure, is this point on the left, is this a colored in circle or an empty circle? It's colored in, so I use a bracket. On the right, again, it's colored in, so I use another bracket. So I say my domain is from -3 to +3 with brackets on both. The range is about the y values. So in other words, what's the bottom of this graph start at to where does the top of the graph start at? Well, it looks like it starts at the bottom here. The bottom y value there is 0, and then it stops all the way up at 3. So I say the range would be from 0 to 3, and since it looks like the graph is actually touching 3 and touching 0, we use brackets again. Let's do another example. Now, think about it. First of all, does this pass the vertical line test? Sure it does. So this is a function. Is this graph continuous or is it individual points? It's individual points, so I should have individual values for my domain and my range. I'm looking at my domain, going from left to right, as being the x values would be -3, -2, 0, 1, and 2. My individual y values, starting from the bottom, would be -1, 0, and 1. Notice that we had some repeats for my y values. Again, I don't care about that when determining whether it's a function, and moreover, I don't need to list those values that are repeated out more than once. Okay, let's do it again. In the next example, I've got a circle drawn here. Now, again, would this pass the vertical line test? Well, no, of course it wouldn't. If I just draw a vertical line there, obviously he's touching the graph at two different points at the same time. He's not a function. Okay, now let's throw these guys away, and let's talk about the domain and the range. The domain of this guy, well, let's see, the domain again is the x values. So how far to the left does this circle start at? It looks like it's starting right here at 0. Where does it end on the right? It looks like it's stopping right here at 5. So this circle's domain will be from 0 to 5. It's touching, we use brackets. The range will be how far down does it go? Well, it looks like it bottoms out right here at 1. and it tops out at, what is that, a 6? So it's 6. So, and it's actually touching those values, so brackets. And that's your domain and range. You guys can try this one on your own. Okay, the last idea is what we have when we have functions that are equations. We call them function rules. And all a function rule is, it's an equation that relates your inputs and your outputs y. This is an example. Y equals 3x squared minus 5 is a function rule, but it's just an equation that relates x and y. Now there is an idea of something called function notation, and we call this f of x. Now this is f of x. This does not mean f times x. You cannot separate those by dividing the f or the x. That means the function of x, or the abbreviation is f of x. F of x is the same thing as the letter y. So in the problem up above, where I have y equals 3x squared minus 5, I could have easily written that as f of x equals 3x squared minus 5. It means the same thing. Now, evaluating functions. Again, what I want you to do, if I want you to evaluate a function, is I want you to plug a value in for the input and then find the output. Let's take a look at this example right here. If I have y equals 2x squared minus 3, and I'm telling you to evaluate it when x equals negative 4, what I'm telling you to do is just replace x with negative 4 and find the y value. Now, finding this, I'm just going to follow the order of operations. I'm going to get y equals 2 times 16 minus 3, so y equals 4 to the 32 minus 3, and so y equals 29. So the answer is when x is negative 4, y is 29. I'm going to go old style on here. In the last example, let's go f of x equals, say, negative x squared minus 5x. If I give you f at negative 2, what's the answer going to be? Well, here I'm telling you that x is negative 2 because what I've done is I've replaced the x in the parentheses with that negative 2. What that tells me to do is replace all the x's on the right side with a negative 2. When I do this, now I'm just, again, following the order of operations. I do the exponent, so negative 4 plus 10, so the final answer is 6. So we say f at negative 2, or the function at its value at negative 2 is 6. And I've just evaluated that. And that ends the lesson. Have a good evening.